In this video, we're about to understand how cis and trans isomers work. So the fundamental concept behind this is essentially understanding that, the cis and trans, if we consider the chair conformation, right, it's not necessarily directing to the equatorial or the axial plane. So just as a fresh memory, so whatever is pointing towards the upward sides, or imagine you're watching this, right? You're standing over here and you're watching this sheet, like you're watching it from the top, right? So whatever's pointing towards you then is the axial plane. And now if you were to stand over here instead and watch it through, just like directly over here, like you can't see the top, then you're gonna see the equatorial phase. And just referring to the axes, if this is an axis over here, real fast, this is the x-axis, this is the y-axis. Whatever's pointing towards the up is going to be obviously the axial, and whatever's going the y direction is going to be equatorial. Okay, now going back to the question, construct and draw chair conformations for cis and trans. 1,2 cyclohexane diol. Whoops, couldn't say that. But okay, so how do we figure this out? Well, if you don't know how to name this, then you should probably go find a video that will help you explain it if it's out already. But what we have to understand is this essentially. So hexane, is unique in the sense because it's very strain free in its structure. So let's look at this chair conformation. And the chair conformation is just another way of writing the hexane. So here we go. All right, so cyclohexane, by the way. Okay, so if we're trying to figure out what cis and trans is, all we have to do and understand is that, okay, either we have, no matter what you're looking at, what carbon you're looking at, it's going to have a up and down face. And what does that exactly mean? So if you were looking at this carbon over here, right? This carbon here is going to have a axial face and an equatorial face. Now let's look at the axial face real fast. Axial face. So the axial face is pointing upwards, right? Exactly. This is an example just to make you understand what's happening. And if the axial is facing upwards, that means that the equatorial is facing downwards. So there are two possibilities. Either is facing upwards or downwards, the face. Okay, that's sorted out. That's cool. So what does it mean when it says in trans? What it really means is that the carbon that's adjacent, or whatever the carbon is, really, it could be on this, it could be on this carbon, it could be on this. Wherever that substituent is attached, it has to face in the same direction. So if we were to consider this carbon and we were to look at this hydroxide over here, that means that this hydroxide is actually pointing upwards. So therefore, these two are basically both pointing upwards. So therefore, it's a cis isomer. But if it were pointing downwards, that would be a trans, because remember, trans is just on the opposite isomers for the substituents, and then the cis is on the same side. Okay, so now you might be asking, how do we figure out what's on the top and what's in the bottom? And it's pretty simple. Like, okay, so you have a question, you gotta figure this out. Let's look at this question. So they're asking us to figure out the chair conformations for cis and trans 1,2 cyclohexanediol. Okay, so here's the first isomer, okay, or the chair structure. And remember, this is another thing that we have to understand is the ring flip. So that is for a different video, but just to boil it down real fast. So we have, let's say we have, what I like to see is focus on this line over here. What does that really show us? It's just going to help us understand how to ring flip. So if this is going upwards, and imagine this is an axial, right? This is an axis, right? So this is going upwards. It's positive in slant. Therefore, if we were to perform a ring flip, that's going to have a negative slope. So check that out. That's an interesting thing to point out over there. But we will talk about this in a different video, so don't worry about that now. Okay, so now how do we figure out what's cis and trans? Like, how do we figure out the substituent's face? Now, what we have to understand is that for the axial, zoom in over here. Now, let's say our target molecule is right over here, and we're trying to figure out, okay, the substituent, is it going to be axial up or down? Now, what you have to understand is you have to follow your movement. The F is missing, but follow your movement. So what does that exactly mean? Now, if this were the target carbon, and we're just thinking about axial for now. Now, is this axial, for this carbon, is the axial going to be facing upwards or downwards? Well, I'm not sure. Well, no worries. So look at this carbon. If we were to move it from the right side, going all the way down, that is going downwards. And if you go from the left side to the carbon target carbon, it's also going downwards. That means the axial is actually facing downwards as well. And if we were to figure out what the axial is, whoops, that's kind of thick. Excuse me. So if we were to figure out what the axial is, that means the equatorial is the opposite. If axial is facing down, then the equatorial is facing upwards. And that should be pretty straightforward. From this point onward, like, we can figure out whatever all the faces are. And if the faces are facing upwards and downwards, then that's a trans. If it's facing in the same direction for equatorial and for axial, then it's going to be a cis. Now you might be like, okay, why can't we actually do this instead? Now here's an example, right? Now, if we were to look at this example and we were to focus on the carbon over here and over here, we're like, all right, so we have the movement. Okay, so is the axial going to be up or down for this? All right, let's see. It's going upwards. That's going upwards. So the axial is facing upwards, just like we said. And the equatorial is facing downwards, just like we thought. Okay, so the point is, essentially, once you're able to, okay, so if we look at this molecule over here, it's facing upward, and this is facing downwards, because we're looking at the substituent hydroxide. As facing downwards, as facing upwards, that's going to be a trans. Period. Pretty simple stuff once you figure it out. Oh, but I didn't answer my question. So if this is facing upwards, and you might be like, okay, why can't this face upwards as well? That's not how it works. This is puckered. And what that means, essentially, that's what Aussies use a lot. I'm not sure if that's the thing we use in America, but still, that just means that it's fluctuating. Like, it's gonna, if this is facing upwards, you can't have something that faces upwards here. And that also because of the rule we established. Just follow the movement. Well, hope this made sense.